Call me. Okay. So just a fun. Like I'm not a very dynamic speaker and all. Just would like to give a try. How many of you in your current work, like you have received some security report and you were supposed to take some actions? How do you feel when you see that report, or when your manager sends a mail, there is a assessment report, take action? How do you feel? Like have you ever felt to work on that? It's boring, right? Yeah. Hopefully, yeah, we also don't want to make you bored. We will start off with the session. This is something, I think it's the right time for us not to see it as a boring stuff, because if we see it again, like if we see it that way, then we will be in soup in some time. So we'll see some, we'll in this session, we'll just see some new things that are coming up in the security area. And well, let's see, at the end of the session, we will discuss further on this. So I am Anita, and we have Savita with us. Both of us work for Red Hat and are open source contributors. So today, we will focus on CBOMs, like CBOM, what another bomb, and again, like S-bombs, it's already too much. It's already dumped everywhere. Now, what is this CBOM again? So let's try to kind of decode it, and then a little bit about cryptographic assets. What exactly are cryptographic assets in an organization? Following that, we will actually see the actual problem. What exactly is the problem in the context of security in the current state? And then why crypto agility and crypto inventory are important. So the problem statement here is there is a level of inertia and inhibition when it comes to security from developers' point of view, as well as each of us as contributors. We have certain amount of inertia to act upon security related activities. At the org level also the same applies. So we will define the problem statement and then impact of it, and then understand how an inventory and being agile helps us to get over that. Following that, finally, we will experiment, or we will run through a toolkit called CBOMkit, which will help us build cryptographic asset inventory. And then we'll also see how easy and how handy it is to identify any compliance issues with our IT landscape. So with that, let me start off. So CBOM stands for Cryptographic Bill of Materials. So in simple terms, it's nothing but an object model, a definition of how you have to capture your asset information. So bill of materials, as most of us know, like if you have a product, in a manufacturing terms, if you have a product, a bill of materials is just a statement of what are the components, what are the sub parts of your, make up your product, and from where this manufacturing, like what are the sources that sub part was made from, what was the procured date, and then you maintain a complete bill of materials so that you have an inventory of it and take action. In similar lines, you can imagine cryptographic bill of materials is nothing but an inventory or a definition for your cryptographic assets. So if you have used S-bombs, you would be familiar with this structure in the right, this JSON. So it's the type will be cryptographic asset. The structure remains the same. Within the components, what makes up your application, software application, within the components, explicitly we will capture. This is a cryptographic asset. So this is as per the Cyclone DX definition. With this basic information, we will move on to what exactly are cryptographic assets. So what are these? These are the core elements that are used to secure the data at rest as well as in transit. In every application we develop, right? So whatever open source projects we are contributing, they are end of the day some applications which either which work on some data in the business world, right? So how are we implementing the security aspect? Like how are we encrypting the data that the application handles, and what are the signing methods to ensure integrity we are following? So these things, like cryptographic assets, are nothing but the elements that are used to secure the data that the application handles at rest as well as in transit. In simple terms, they are the enablers of cryptographic functions like encryption, decryption, digital signature, and secure communication. So what you see here is a list of all such cryptographic assets that we use in our day job. So I don't want to get into the details of it, but this is just a summary of what could be a cryptographic asset. Now, enough of basics. Now, we will actually define the problem statement. Why this session? That's what we need to focus on. So here these are listed here are a few of the real world incidents that have happened in the past. So we did a study on this, and there are two important points to note. One is the compromise, and another one is contain. So in security world, so when an adversary and an attacker compromises, they breach some weak link in the application or in your infrastructure. When they breach, how long it takes for them, say they get hold of some private key or a password, how long does it take for an adversary to use that password and access the system and get access to the sensitive data related to business or anything. So that's what is captured as approximated time to compromise. It depends upon the skill set of the hacker and then the kind of resources they have, the level of exposure, the level of layers of security the organization has implemented. So that's what we have captured in approximate time to compromise. So in case of SolarWinds scenario, the time taken to compromise from adversary's perspective was just from hours to days. It is just an approximated calculation. Whereas from an organization perspective, who were running that particular version of SolarWinds, how much time it took for them to defend and protect themselves, to contain the attack. So that's what captured here. So as you can see, this is just we have just taken 3 incidents for a quick identifying the problem statement. As you can see, the compromise time and the containment time, there is a huge gap, right? So a breach can happen from hours to days, but we are not able to contain within in measure of days. It extends, it goes from weeks to months. So the larger the time gap, the larger the exposure. Your data is exposed for a longer duration. So that is the problem, and this is what we call as the state of inertia. We want to just term it as a state of inertia. So why is this inertia there? There are a lot of early vulnerability deductions, and then you have a whole group of security team and a lot of security measures and auditing going on. But still, why is there a state of inertia? Why are we not able to immediately act upon some incident? So that's what we call inertia, and the way to get rid of inertia is build a complete agility, at least in the security practices, complete set of agility in security practices. So just a little bit additional points, like what could be the reasons why we might have in our organization, like why we are having this inertia in the security practice. Like as developers, we ourselves have a little inhibition when it comes to responding to assessment reports. So if that's the case, if at the infra level, every level it has to be done in a very proactive way. If the infrastructure has any legacy systems for whatever reason, if they are not migrated, and if the patch management process is not effective, or if there is, this third point is very important, a lack of visibility, a complete lack of visibility of all cryptographic assets used across the systems in the IT landscape. And in silo teams, these are standard reasons that we could call out. So the 3 critical reasons are outdated systems, slow patch management process, lack of visibility. So these are key drivers. Apart from that, there could be various other reasons, but they are the key drivers which could induce inertia in the security process itself. So so what we are proposing here is, it's not just our proposal. NIST has done a detailed assessment, and not in the context of just handling this inertia state. There is also another growing need where the security practices have to be agile. That is agentic AI adoption, and then the rise of quantum computing. These two are like, they will, the speed at which attacks can happen, the speed of the vulnerabilities, the speed at which the threats can happen, the algorithms can be broken, is all like, it will all be very fast with agentic AI adoption and quantum cryptography. So for that reason, there are new algorithms coming, and we as organization, we'll have to quickly adapt to those changes. So it is essential now to be very agile in our security practices. Apart from that, we also have new compliance rules because of various other factors like security threats identified. So responding fast is kind of mandate, is what I would say, if you have to stay ahead of the threats. So how do we get to that agility state? Now that we understand the problem of inertia, the hidden risk, which is the problem of inertia, though we can do all reporting, there is this hidden risk of not acting immediately. So now we understand the importance of agility. And then how do we get to that state? What exactly we have to do? So that for that, Though this is not directly proposed by NIST, the standards organization, this is a reference framework that they have pointed to, where they gave, for an organization, they can go through these levels of assessments to take to the highest level of maturity model. So if you see at the level 4, the highest level of maturity model demands an organization to be able to replace their cryptographic assets on the fly without any downtime, like in a running system, without any impact to the business operations or business functions. So that is the level 4. Today, can we do that? In our running application, if we have to change an algorithm or if we have to change a crypto mechanism, we have to do a complete redeployment, and then there are a lot of steps involved. So if we have to be at that level, we have to get into a state of abstraction and then bring in a complete automated way for that. So that level of maturity has to be attained. So an organization can take this as a reference framework and start measuring and building and they can build steps to improve themselves. So this is for reference. Okay, now that you know agility, now how does agility come into play? So can we act fast if we don't have sufficient enough information? If we don't have knowledge on something, we can't do it. We can't act fast. So that's the idea. That's the fundamental truth. So based on that, in the same philosophy, actionable real-time inventory should be there. It's a must for crypto agility. So that's the idea of proposing inventory. So this is just a high-level overview of how a CBOM-driven inventory can enable agility in an organization. So we initially spoke about CBOMs, which gives a which gives a clear structure for the cryptographic asset and properties where it is used. So all those CBOMs, so at the bottom we have possible systems in an IT landscape. So right now we are just covered like source code repositories, tools like key management systems, network traffic analysis, and then runtime environment. So from all these locations, like there could be certificates that could be that could be there in a runtime environment. There could be algorithms that we are using in our applications. So have a centralized inventory in the form of crypto inventory, and it's a collection of CBOMs. On top of it, initially to start with, we can have manual works, like we can do agile practices, like we can take actions. If there is a new crypto rolled out, we can at least call out these are the components that are being impacted and take immediate action. At a later stage, we can bring in complete automation, like risk and compliance assessment itself can be completely automated based on the inventory we have. Additionally, we can have crypto agility engine, which can take corrective actions on its own based on the rule set. So this is what we are proposing here as a unified crypto inventory would essentially enable agility. So with this basic information, I'd like to hand over to Savita.
Yeah, thanks Anita for the detailed overview about the different perspective on a security point of view. So yeah, let's talk about the another kit called CBOMkit. So it was initially developed by IBM. And recently, I think 3-4 weeks back, it was adopted under PQCA, which is Post-Quantum Cryptography Alliance. So basically, it's a kit for CBOM. It is designed as a framework which helps in managing the cryptographic visibility, compliance, and governance for the software system. Now, we are completely leveraging on this CBOM kit to get the compliance report. When we say compliance report, what does it contain? It contains basically your cryptographic assets present in your code. So basically that helps any developers or users to know about the CBOM and to know about the cryptographic assets present in their code. So now, as we are relying on CBOM kit, so to get that compliance report in CBOMkit, which all are the modules which will help us to finally get that complete report. So the modules is let's go in depth of those modules as given on the right side of the diagram. So basically, like there are 4 modules which complete play a role in order to get the final report. So we have a CBOM generator. So in CBOM generator, we have 2 parts, Hyperion and Thi. So Hyperion is like, it basically scans the source code and find out the cryptographic assets present in the project. So today, I mean, as it's a start of the project, so like it has a support for only 2 languages, which is Java and Python. and there is a room for adding or enhancing this kit to support more languages going forward. And we have this another scanning tool which basically scans the container images. So once we get the CBOM JSON from this generator, it's time to visualize it and see what are the cryptographic assets present in your project and what action has to be taken care. So that's where we have this module called CBOM viewer, which will give the context of the cryptographic assets present in the generated CBOM. So now we have one more module called compliance engine. So it's basically evaluate the generated CBOM against a set of policies. So today it supports the quantum safe check, but user can add their own policy depend on the use cases. So once we have generated CBOM and once we visualize it and verified against the policies, it has to be stored somewhere, right? So that's where we have this CBOM repository. It's basically a central storage mechanism for your entire CBOM, and it also supports some RESTful APIs which we can use for the integration purpose for the extra use. So now let's see this in action to understand how we can leverage these modules and kit to do to analyze the cryptographic assets. So yeah, in the demo, basically we are discussing two parts. One is okay, if I have a project, as I mentioned, it supports only two projects today, languages today, Java and Python. So first, we are completely relying on CBOMkit. CBOMkit provides a very good UI to visualize any assets present in our project. So we are just relying on that to visualize the data. And the second demo, what we are focusing, we have a GitHub Actions. So with the help of GitHub Actions, we can integrate to our work, or you can say project, and by integration that, we can complete our end-to-end workflow. So that will help us to get the data or cryptographic assets presence in the early stage. So based on that, we can take some actions. So yeah, let's look into this quickly. So the first one, as I mentioned, we are completely relying on CBOMkit. So this is as I mentioned, it is recently adopted under PQCA. So yeah, this is what we discussed till now. I just relied on this quick start and I deployed it already on my cluster. So it is running here. Using Docker Compose. So it is exposed on localhost 8001. So if you see here, this is a pretty much UI it looks like. So here we can specify our project URL for which we want to scan it. That is one way. Another way, in order to visualize the report, if you have your CBOM JSON already generated by some other way, you can upload that. So these are the two ways you can get the final report which shows about the cryptographic assets. Now, if you see here, these are some things which I have tried it out before this session. So this is where the storage looks like. So whatever we try, it maintains that history. So this is where we have CBOM repository, CBOMkit repository storage, which we discussed here. So basically, it uses Postgres database to store the data. All right, now let me quickly use two repos. So this is the small GitHub repository README we have written, some setup instruction we have tried it out. So these are the two repos which we are using today. Both are Java based. Though I am not a Java programmer, I am basically a Go. So I just relied on the AI to get this repos, which has one is compliant and one is non-compliant cryptography stuff. So let me copy this project and go to CBOMkit and I'll paste it here. And when I click on scan, it internally calls the WebSocket to analyze the code and reports. So let me click on scan. So if you see, it is cloning and scanning the project. Now, when I give this project, right, so it has scanned and it finally provides us the detailed information about the number of assets found out in this project and whether this is a quantum safe or not. So this is what we can visualize the pictorial view of all this data present in this project. So if you see here list of assets, so this indicates the cryptographic assets present in your project, which is this client encryption Java. So if you see here, like there are, if I click on this non-quantum safe, so it indicates that like there are 3 cryptographic assets which are not quantum safe. So those are in color wise it is indicated here. So this shows for you or as an organization that, okay, this is the right time to take some actions and to be ready for the quantum cryptographic going forward when actually quantum computers comes into the work. So this way, if we get the data in the early stage, it will be very helpful. So if I click on some like quantum safe, right? So basically there are nothing quantum safe here, but we also have not applicable, right? So this not applicable indicates there are crypto which are like asymmetric crypto, symmetric crypto. So that indicates that, okay, for symmetric one, we can increase the key size and we no need to worry from the quantum point of view. So that can be handled that way. So those are symmetric based algorithms also can be a quantum safe if we increase the key size. Yeah, and you can download the generated CBOM from here for your further use to understand, okay, how the structure looks like. And yeah, this 8 type crypto asset indicates the cryptographic assets present in the entire project. So like some will be basic and some will be advanced one. So basic, when I say, it can be symmetric, asymmetric, hash, and when it is crypto functions, it is like a digest or TLS, something like that, the algorithm which uses the basic primitive and try to generate on based on that. So this is the first part of the demo where we are completely relied on CBOMkit. Now in the second part of the demo, so as like in your production grade environment, you cannot take one repo and go and scan through UI, right? Until and unless they support the API for scanning. So API for scanning. So that's where we are relying on one more project under PQCA, which is CBOMkit Action. So basically it supports the GitHub Action support today, so that we can leverage that completely to understand how we can integrate these GitHub Actions. So these are the, So these are the 2 projects which I showed in my repo here. So let me quickly do code changes here before I show the GitHub Actions file. So I'm quickly changing the adding the change, readme change, and I'll save it. So the GitHub Actions start running. Meanwhile, I'll go to another repo and do the same thing, which is like changing the readme and committing it back. So here also for the changes, the GitHub Actions will run. So this is the one which we are interested. So meanwhile it completes. Let me go and show the GitHub Actions which we used. So basically we are acting on both pull and push request. And this is the plugin used in GitHub Actions to scan the code. And finally, after scanning, we get this JSON. And we are relying on the compliance check API provided by the CBOMkit. And with the help of that API, we are getting this compliance report as an output. So this output is nothing but it's a JSON format through API, but when you give it to the UI, it looks like something like that, right? So this output basically contains information about whether it is compliant or not compliant. So based on that JSON data, we can act on that. So now let's go back to our action. See here, like for one of the repo, it is compliant. And we can get the summary saying that, okay, it is quantum safe. And for the other repo, it is not quantum safe. So we get the like check mark saying that, okay, this is not quantum safe. And it's the time to act on the issue and work on those. So this is how the GitHub action looks like. And here we like, the use of GitHub action help us to integrate in our regular workflow, which will help us to get the issues in the early stage and act on that. So yeah, this is all from the demo point of view. Now let's look at the structure. Like in the first slide we saw, right, CBOM, and what is the main component which is present from CBOM to SBOM. So this is how the structure looks like. Let me show you the enhanced one. Like I downloaded the one which is one which is generated. So this is a CBOM JSON. Basically, it contains your metadata, which is nothing but the which repository, from which repository this JSON got generated, and the component. So this is important. So in component, it's basically a cryptographic assets, right? So which is nothing but here, cryptographic assets, and that component contains the different crypto properties. So it can be algorithm, protocol, or like related crypto materials. So here for this particular project, which is like client encryption Java, there are two types of assets. There are two types of crypto properties we found. One is based on algorithm, and another one is based on related crypto material. And this related crypto material has support, I mean, it has info about this public key or like private key. It has support for all these listed keys. So if you see here, it has showed that type. It is not common for every project. It depends on the project to project, what crypto assets are involved there, and what are the crypto properties are utilized in that project. So it's completely depend on the project to project. It's just the structure, how it looks like. So the idea is to give the glimpse of the structure, how the CBOM JSON looks like. Yeah, that's all from the demo point, session point of view. These are few references, and yeah, feel free to connect, and thank you. Any questions?
Just 1 second, sorry. We planned to originally end this session. Just few points. Like the key takeaways from this session, we expect are like for new contributors who are interested in newly contributing, there is this CBOMkit project by PQCA. We have captured the QR code here. Right now, this kit supports only Python and Java, and selected libraries only. Like anyone can contribute. It is in the nascent stage. It will mature. That is one point. For developers like who are already contributing to open source, please, as Savita demonstrated, please try to integrate into the CI, like GitHub Actions, and see if early detection of crypto compliance is measured. And again, it is pluggable. Like we just have only PQC compliance rules written there. We can enhance to add additional compliance rule as required for our project or organization. So have a look. That is only one thing I wanted to mention. Thank you for your, any questions?
Any questions, guys? All right, okay. So thank you, Anita and Savita, for the wonderful session.